Hello. This video captures the substance of what we did in the Python area in topic 6. So, the topic concerns tuples, lists, aliasing, mutability, and cloning. And it seems as though this is a bit of a scary list of topics, but it's not really, and I'll take you through everything. Um, these The concepts on the first page relate to specific data structures, and we do actually need to store and retrieve data. So we're going to have a look at two more data structures this week and look at the operations on those. See what we can actually do with those um, data structures. So starting with lists, lists are intuitively very much what you'd expect. There are lists of certain types of objects. For example, the names of books that you should be reading this year at IFG. Numbers having given with a particular significance, like might be the times of the tide on the coast, or might be a list of for example, the solutions to various problems, or the list might be to do with shopping, for example, foods or Christmas presents, and so on. I mean, we're all familiar with the idea of a list. And typically in Python, the items on a list are of a specific type, but could include objects of more than one type. And what we're interested in now is firstly, how a list is represented in Python. Secondly, how items are added to a list. And thirdly, how items are removed from a list. And it seems to me as though there's not very much else that we could do with the list. We need to be able to create a list, we need to add items to a list, and we need to perhaps delete items from the list simply by crossing them out. So let's take this a little bit further. If you think about these latter 3 points, the implication is that you can create an empty list and then modify it by adding elements, items, objects, or removing existing objects. And this is to say, in Python, lists are mutable. Okay, mutable just means can be changed, have the capacity of being changed. And in this connection, notice that we can also talk about the first and last elements. And in fact, more generally, we can talk about the nth element of a list. And it also makes good sense to speak of an empty list. Uh, you know, immediately on creation of the list, of any list, it is empty. There's nothing in the list. So that's something that we need to look at. And you might wish to think about whether two lists are essentially the same lists if the same items appear on each list. And maybe forget about the particular order of items in a list. If the lists contain exactly the same, for example, breakfast foods and foods bought from Tesco's, are they essentially one and the same list? Well, we'll come to some sort of answer to that question a bit later on. But this property, this general property of lists, is in contrast to tuples. For example, we can talk about an empty tuple, or the nth item of a tuple, and that's to say a tuple is like a list, or rather like a list, orders its elements, but possibly the order of elements in a tuple is absolutely essential, and you can't move them around and still have the same tuple. So very often the elements of a tuple might be of different types or sorts of objects. Right. So in the case of both lists and tuples, a list can contain uh, lists as elements, or a tuple can contain tuples as elements. So in fact I could have a tuple and each element could itself be a tuple, and each of those tuples actually could contain a tuple as the ith member of that tuple. So generally a list contains as objects or elements objects of the same time. So a list might contain uh, a list of numbers, for example. So just moving on a little bit, asking you the question, what is an alias? Well, it's just another uh, name for the same object. That's to say, it's it means also known as. I mean, some things are called by different names, but the two names actually uh, refer to exactly the same object. Lists are mutable. If A is an alias for B, then if any change is made to list A, the change will be reflected in list B too. Tuples aren't mutable, however, so we don't need to be bothered by this at the moment. If we need to work with a tuple in order to, say, sort it, if it's a tuple of numbers and I wish to sort it according to ascending order, or maybe add elements to it, the only thing you can really do is to clone A. I make an identical copy of A and then make changes to the clone of A. So just summarising what we did last time in Python, we looked at functions, and that's areas of particular importance. We're going to use functions quite a lot. We spoke about decomposition of a program in order to create a structure to the program. We looked at the importance of abstraction, where we can conceptualize something effectively by suppressing inessential details of what we're modelling or trying to represent. So from now onwards, we certainly will be using functions quite a lot. And we've seen various types of objects. We've looked at ints, floats, bools, and I think it was last time we looked at strings. So we're introducing these two data types, tuples and lists. And I've already mentioned aliasing, already mentioned mutability, and already mentioned, in a fairly superficial way, cloning. So we need to get a better grip on that. So first of all, let's see how we represent a tuple in Python. Very easily, we use rounded brackets and we separate each tuple by means of a comma. So here we go. TE is a variable which has been assigned this little object here. It's round bracket, immediately close, puts a close bracket there. This represents the empty tuple, nothing in between the two brackets. Here I'm assigning to T, so T is a tuple variable, the following tuple which has three elements, and it's a mixed tuple because I've got two integers, 2 and 3, and I've also got a string, ifg, in between. So let's see how we can use T, this variable T. We can access particular components by writing T square bracket 0, and that actually represents the first element of the tuple, which is 2. So the second element is ifg, the string, and the third element is T2. So that's T0, That's T1 and that's T2. So what I can do with tuples is to um, concatenate two tuples, or if you prefer, join two tuples. So I've got this three tuple, what I mean by that is that it's a three-element tuple, and I'm going to join it onto the front of the tuple consisting of two elements, two integer elements, 5 and 6. And this evaluates to, this stands for the tuple 2 MIT 3, 5, 6. And I can slice a tuple, cut it open, if you like, by writing, I'm going to slice it from the first element, and I'm going to get the next, I'm just going to end at the element T2. T2. So let's have a look at that. So that evaluates to first element, which is IFG, and I'm going to end at element 2. I mean, that's the limit, it's the stop value. So I'm just getting this string. It's a one element tuple, and I represent that one element tuple by putting the element in and writing a comma afterwards. So have a look at this. I want to slice this tuple up, which, so it's this tuple here I'm working with. And I want to begin with the first element T1, so that represents this element here. And I'm going to stop at element T3. So I'm going to include T2 as well, but I'm stopping. I'm not going as far as T3. So I get two elements. That's a two-element tuple. That's the string followed by the element T2. T2. And I could use the function len, which is short for length of the tuple T. Length of the tuple T is actually three elements. So let's move on a little bit. Whoops. And one thing I can do, which is quite useful sometimes, is to use tuples to swap variable values. So, for example, if I've got variables x and y, and the value of x is y, and the value of y is x, can I swap the values of x and y around? Well, to do it in that way is incorrect, because if you think about it, if I'm giving x the value of y, and then I'm giving y the value of x, which is now y, I'm not swapping the values of x and y around. I'm setting them both to y, which is wrong. I mean, logically, I can actually assign the value of x to temp, so I'm keeping the value of temp safe, and then I can assign to x the value y, in which case I've overridden the original value of x. And as a third step, I can actually set the value of y to the temporarily saved value of temp, which was the original value of x. So here, I've actually setting x to the value of y and y to the old value of x. But a dramatically simpler way of doing it is to assign to the tuple x, y, the values of the tuple y, x, respectively. So the value of y is going to go into x, and the value of x is going to go into y without further ado. Try it out. Just run a little program. Just run a little program to see what happens. All right. So here I've got a function definition. So the function name is quotient and remainder, and it takes two values, x and y. So this is the definition, end of definition. Sorry, definition, end of the name of the function is terminated with a colon. So if I assign to Q the result of dividing x by y, and I assign to the variable r the remainder on dividing x by y, then the function can return that pair of values, q and r. So I'm returning a tuple. So this is the first time we've seen a function return a tuple. So if I call the function with the two integers 6 and 5, I can assign this tuple, which consists of an integer variable quotient, quote short for quotient, and rem short for remainder. That becomes the value of the tuple that's represented by applying the function to two numbers. And I get a pair of results in a tuple. That's quite handy. It's quite interesting. Quite useful at times. And what I'd like you to do is to think about the following function: get data. Get data takes a tuple as argument, and it returns the following. It returns this three tuples. So it's actually a tuple with three elements. And what I want the function to do, I can express almost diagrammatically by representing the tuple by three elements. And each element is a tuple, right? 1, 2, 3. And each tuple consists of a number, an integer, and a string. Integer and a string. Integer and a string. And what I want the function to do is to calculate in two tuples the following. I want a tuple consisting of all the numbers that I've removed from this tuple here. And I want a second tuple which contains the unique strings occurring in the original tuple. So in other words, I put a word into this tuple if the string, like for example this string here, doesn't already occur in this tuple. In other words, what I'm interested in doing is to collect all the unique strings from the tuple, which I'm calling a tuple. So have a look at this. I initially set nums to be the empty tuple, and I set words to be the empty tuple. And then I loop over all the elements of a tuple. So the value of t, first of all, is this, then the second tuple, then the third tuple. So have a look at this. For each value of t in the tuple, what I'm going to do is to collect all the numbers together. So nums is the starting off with the empty tuple. I'm going to concatenate it with the first element of this tuple here. This is t0, remember. This is tuple t0. And I'm going to first of all check to see whether sorry, forget about that. I'm just going to add it as a, I'm just going to concatenate it to the empty tuple nums. And that's the first time around the loop. The second time around the loop, I'm actually going to give nums, the variable nums, the value of the tuple consisting of t0 and followed by t1. Third and final time round this loop, I'm going to set the value of nums to be the old value of nums, which is t0 and t1, followed by t2. Okay. Um, each time I access a particular member of the tuple, for example t0, uh, what I can do is to check whether or not T1, that's the second element in the tuple, occurs in the words tuple that I'm building. So in other words, but I only do that if it doesn't occur in words, if it's not there already. So, for example, if I look at this string here, what I'm going to do is to put it into the words tuple only if it doesn't already occur there. All right. So what I do in that case is to add T1. So it's a single element tuple to words. The tuple that I've built up in looping around this particular for loop. So when I've finished doing all that, I can set the variable min n to be the minimum of all the numbers in this particular tuple. I mean, min is a system-defined function that returns the minimum of a tuple of numbers. And I can set max underscore n to be the maximum of all those numbers. And I can assign the value to this integer variable, unique words, the actual length of the words tuple. So words tuple might just be one. It depends, you know, how many unique strings are there in the tuple. Then I can finally return min underscore n, max underscore n, and as a third element of this tuple, um, I guess the the tuple of unique words. And so, for example, the tuple might be this for tuple. It's got four elements, and each element has got a number. It has 1, 5, 19, and 4. And each tuple element contains two members. The second member is a string. So it's string 1, string 2 here, string 3 here, but string 3 again in the fourth item of the tuple. So what's needed is to build up two new tuples, first containing all the numbers, 1, 5, 19, and 4, and the second tuple to contain the unique strings, i.e. it's just got three elements, three strings. String 1, string 2, string 3. And the program that does it is the one I've just shown you. All right. But here I think yeah, so you could, if you wanted to, just cut and paste that. But I think I'm giving you this as a Python file, and I'll put that into topic 7, I think we're on now. Okay. So if the tuple test is 1 Luana, followed by the tuple 2 Sultan, 3 Christopher, 7 Christopher, then if I call the function on this tuple test, then I'm going to get the result out, and hopefully it will be correct. So, how do lists differ from tuples? Well, I'm afraid that this is something I'm going to talk about in the most recent topic. So you'll get this on the face-to-face session on Thursday or the remote session on Friday. Okay, so thanks for listening. Hope this helps.